Welcome, AI architects! Today, we are exploring how to unlock unparalleled accuracy and tonal precision by setting persona contexts in our generative AI prompts. Let's give our models a character. Welcome to the fascinating world of persona contexts. When interacting with advanced models like Anthropic Claude or Meta Llama on Amazon Bedrock, you are not just querying a rigid database. You are collaborating with a highly adaptable cognitive engine. If you just ask a generic question, you get a generic textbook answer. But what if you need specialized expertise? By assigning a persona, you instantly calibrate the model's vocabulary, tone, and level of expertise. Assigning roles or personas to the Claude models aids in improving model performance in several scenarios, which in turn improves the model's tonality. For instance, you can assign an expert role for executing a certain task, such as, you are a seasoned children's book author, or you are a business expert. The moment you inject this persona context, the LLM mathematically shifts its probability distributions to favor words and phrasing aligned with that specific character. Woof. This isn't just roleplay. It is a highly effective parameter tuning mechanism driven entirely by natural language. Let's see how dramatically this can change an output. This flowchart illustrates the cognitive shift. A generic prompt triggers generic weights, yielding bland responses. But a persona-driven prompt dynamically activates specialized vocabulary weights, resulting in a highly expert, accurate, and tonally perfect response. How deeply does a persona affect the complexity of the generated text? The impact is absolutely profound. Let us take a highly complex topic, like explaining rainbows in the sky or quantum physics. Without assigning a role/persona, the answer may be complex to understand. The model might default to a dense, PhD-level mathematical breakdown of optical refraction or quantum superposition. But what if your application is an educational app for young children? You simply set the persona. Imagine you are a kindergarten teacher and have to provide an explanation for rainbows in the sky to the children. Amazed. After adding the role/persona, you can see that the output response aligns more with the child's complexity level. The model restricts its vocabulary, introduces playful analogies, and adopts a warm, encouraging tone. In enterprise applications, we use this to align the model precisely with the company's brand voice. Whether you need a formal legal advisor, an empathetic healthcare assistant, or a witty marketing copywriter, the persona acts as your ultimate stylistic guardrail. Observe the divergence. The identical topic of rainbows is routed through the persona filter. With no persona, we get dense optical physics. With the kindergarten teacher persona, the model dynamically simplifies the output for perfect audience alignment. To implement personas robustly in production, we must understand the architectural difference between system prompts and user prompts. In modern messages APIs, such as those used by Anthropic Claude on Bedrock, prompts are structurally divided. System prompts can define the personality traits, communication style, and domain knowledge the AI should exhibit. Why don't we just put the persona in the user prompt? Because user prompts are dynamic and often contain untrusted input. If you mix the persona definition with the user's question, the model might lose focus on the persona as the conversation gets longer. By placing the persona strictly within the system prompt parameter, you establish the overarching, unbreakable laws of behavior for the entire session. Through system prompts, you can specify a helpful, informative persona, ensuring that the FM uses language and knowledge appropriate for the role. This guarantees that even if a user asks a bizarre question, the model will answer it firmly from within the perspective of the assigned persona, maintaining absolute consistency. This structure is vital. The system prompt establishes the global persona rules independently from the user prompt, which provides the specific task. They merge in the LLM context window to produce a rigidly consistent persona-driven response. Let's jump into the code and see exactly how to implement a system prompt persona using the Amazon Bedrock API in Python. When invoking Anthropic Claude 3 models, we utilize a strictly formatted JSON payload to separate our system rules from our message history. We declare our persona in a dedicated variable. For example, setting it to, you are an AI assistant, Or, you are an expert AI assistant. You will answer questions in a succinct manner. We then insert this directly into the system key at the root of the API payload, completely separate from the messages array. This separation mathematically enforces the hierarchy of instructions within the Claude model architecture. The model treats the system key as its fundamental identity parameter. Let us trace this logic step by step in a robust Boto 3 script. Let's trace this Boto 3 logic step by step. We instantiate our Bedrock runtime client. We then explicitly define our system persona string, assigning the role of an elite cybersecurity expert. Notice our payload dictionary. We map our persona string directly to the system key. This is completely isolated from the messages array, which contains the user's actual question about prompt injection. We also lower the temperature to 0.2 to ensure the expert's response is highly analytical and precise rather than overly creative. When we invoke the Claude 3 Sonnet model, it absorbs the system identity first, then processes the user message through the lens of that identity, returning a breathtakingly accurate, highly technical cybersecurity explanation. It is persona engineering at its finest. Observe the payload assembly. The system key holding the persona and the messages array holding the query are assembled into the JSON payload. This is dispatched via invoke model, guaranteeing a response steeped in a cybersecurity expert identity. Personas are not just for adopting a fun tone. They are one of your primary defense mechanisms against AI hallucinations. Large language models possess a natural conversational bias. They desperately want to answer your question, even if they have to invent facts to do so. In an enterprise environment like finance or healthcare, a hallucinated fact can be disastrous. How do we use personas to fix this? We integrate explicit unknown disclaimers directly into the persona definition. Providing explicit expressions as disclaimers, such as, if you don't know the answer, respond with the following format. My sincere apologies, I'm not aware of the answer, can aid in avoiding any form of hallucination from chatty Claude models. You can literally prompt the model, you are an expert AI assistant. You will answer questions in a succinct manner. If you are unsure about the answer, say, I am not sure about this answer. By embedding this constraint deep within the system persona, you give the AI psychological permission to admit ignorance. It fundamentally shifts the probability calculation, making it far more likely to output your safe, predefined failure message rather than fabricating a dangerous lie. This flowchart maps the cognitive safeguard. When the expert analyst persona evaluates a query and realizes it lacks the facts, it checks its persona constraints. Instead of hallucinating, it safely defaults to outputting, I am not sure about this answer. Setting a persona for a single question is easy, but maintaining that persona over a long, multi-turn chat session requires architectural discipline. As a conversation grows, the context window fills with back-and-forth dialogue. If the persona is not reinforced, the model can experience persona drift, slowly reverting back to its default generic AI tone. How do we lock the persona in permanently? We leverage orchestration frameworks like LangChain, which provides memory components to address this need. When using memory classes like conversation buffer memory, LangChain manages the chat history. But crucially, you can define a system message at the very beginning of the history chain that permanently anchors the persona. On the first turn, send both a system message to set the AI's persona and a human message. On subsequent turns, only send the new human message so that the original system prompt remains at index 0 and isn't duplicated. This ensures the system prompt is only inserted once at the start, and all later turns naturally include the full conversation context. By anchoring the persona at index 0 of your memory array, you guarantee that even after 50 messages, your virtual assistant remains perfectly in character. Let's look at this LangChain code snippet to see how we permanently anchor a persona. We import the system message and human message classes. In our first invocation to the conversation chain, we pass an array containing two objects. The first is the system message, where we define our persona. You are a top-tier software engineering expert. This is the anchor. It sits at the absolute top of the context window. Immediately following it is the human message with the user's actual question. The LangChain memory buffer will now hold the system message at index 0 forever. As the user continues to ask follow-up questions, LangChain appends them to the history, but that elite software engineer persona remains permanently injected at the root of the context, guaranteeing zero persona drift over time. Observe the structure of the memory buffer. The system message persona is permanently locked at index 0. As human and AI messages stack up over time, the model constantly references index 0, ensuring continuous persona consistency across the entire chat.
As we wrap up our exploration of persona contexts, we must discuss how we evaluate if our persona engineering is actually working. How do we know if the model is truly adhering to the role we assigned? We use structured evaluation frameworks. Specifically, we can apply the RACA framework, which assesses prompts based on relevance, accuracy, completeness, clarity, coherence, and appropriateness. For personas, appropriateness is the key metric. Appropriateness evaluates the suitability of the content for the intended audience, considering factors such as tone, language, and adherence to ethical guidelines. If we designed a kindergarten teacher persona, but the vocabulary is too advanced, the response fails the appropriateness check, and we must iteratively refine the system prompt. Persona design is an art and a science. It requires continuous tweaking of the system instructions to strike the perfect balance between expertise, tone, and strict constraint adherence. I hope this module has given you the tools to breathe life into your generative AI models. I invite learners to like, subscribe, and visit quicktechie.com for premium and for recently updated material as per latest syllabus and certification prep. Q&A banks, ebooks, audiobooks, full training, interview guides. On YouTube, it may not be a latest contents. This is the iterative evaluation loop. We deploy the persona, generate a response, and evaluate it using RACA. If the tone is appropriate, we lock in the system prompt. If not, we iteratively refine the persona instructions and test again.